Today we're looking at real numbers again, and today we're going to be comparing them. I've already looked at how to find them on a number line, but the objective today is I can order and compare irrational numbers. We'll be working with ordering them later, but today we're specifically looking at comparing them. Which one's greater, which one's less, maybe even are they just equal. So let's look at this introductory problem here. It says, let's say that today the choices for lunch were pizza and cheese sticks, and that Mrs. Park's homeroom and Mr. Abernathy's homeroom both have 25 students. If 1/5 of the students in Mr. Abernathy's homeroom picked the pizza and 24% in Mrs. Park's homeroom picked the pizza, which class had more students pick the pizza option? So we have these two amounts of students in each of the classes represented in different ways. The amount of students in Mr. Abernathy's class is represented by a fraction, and the amount of students represented in Ms. Parks' class is represented as a percent, but they're both part of the whole class. So right now they're a little bit tough to compare, and you might be able to look at them and just know based on maybe in your head you can change 1/5 into a decimal and change that one into something easier to compare, but right now because they're not in the same form they're a little bit tougher to compare. So the first thing today is that we're going to be converting all the numbers to the same form so that they're easy to compare. And for the most part the easiest type of number to compare is usually decimals. Fractions might have different denominators and that could be tough. Percents are pretty good as well, but we're going to be working with decimals. So we're going to change all numbers. You can see step number 1 is convert all numbers to decimal form. And then from there all we have to do is compare the numbers by looking at the place values. So we're going to look at the place value one at a time until we kind of break the tie to see which number is greater or less. So the first thing we're going to do here is convert these to decimal form. So we've converted a lot of fractions to decimals, and you probably know the decimal form of 1/5. But in case you don't, you will set yourself up a long division problem here. We'll put the numerator on the inside, denominator on the outside, and get our decimal here. So 5 goes into 10 2 times. 2 times 5 is 10, and there's nothing left over there, so it's 0.2. So we can write it below this here, that's 0.2 or even 0.2 if we want to write that. For percents are just out of 100. That's what percent means. So when you take 24% to change it to a decimal, you just divide it by 100. And if you divide something by 100, it just moves the decimal over 2 places. So right now, with no decimal written, it's right here. If we're going to change a percent to a decimal, we just move it over 2 places. So this is 0.24 in decimal form. So now we're going to compare these by looking at the place values. So I've got 0, write this down, I've got 0.2, got a comparison circle here, and then we've got 0.24 over here. So the first place we want to look is the ones place, because that's the first thing that's both written for these. But there's a 0 for both of those, so they're tied at that place. So then we go to the tens place to see, and they're both tied at the tens place with a 2 as well. So when we go to the hundreds place, this has 4 and this has nothing. We could write a 0 in here if we wanted to, but if there's nothing written, it's an implied 0. So this has 4 and this has nothing, so that means that this side is greater. When you write a symbol in here to compare, you want the wider part of the symbol facing the greater part and the smaller part of the symbol facing the smaller part. There's different ways to sort of remember this. Sometimes people say like this is a mouth, and the mouth wants to always eat the bigger number. So if that's how you remember it, that's fine. But I just think of it as, the greater part of the symbol faces the greater number, and the smaller part of the symbol faces the smaller number. So to answer the question, it was the 24% in Miss Parks' homeroom that had more students pick the pizza option. 24% versus the 1/5. The 24% ended up being greater. So we're going to be looking at different numbers and comparing them. So let's go ahead and do some of these together problems. I want you guys to write these down and do these with me. So the first one here is 0.27. And then draw yourself a nice big circle to write a comparison symbol in there. And we're going to compare that to the fraction 1/3. So the first thing is to convert the numbers to decimal form. 0.27 is already in decimal form, and 1/3 we could change that to a decimal using long division. So the numerator on the inside, denominator on the outside. This is one you might know already. So 3 goes into 10 3 times. 3 times 3 is 9. and we subtract. 10 minus 9, we can borrow from the 1 there. 10 minus 9 is 1, bring down a 0. Okay, 3 goes into 10 3 times. 3 times 3 is 9, and we subtract. Again, 10 minus 9 is 1. Bring down another 0. 3 goes into 10 3 times, and we're just repeating, right? This is going to be the same thing, 0.3333, on and on and on. So we can go ahead and write the decimal form for that. Wherever we have room, we can write it above here this time maybe, since we already took up the spot below. And we're just going to round it. We're just going to round to the hundredths place. Most of the time, to the hundredths place is enough for us to be able to compare these and break the tie. So let's go through place value by place value to see when we break the tie. So they both have 0 in the ones place, and then this has a 2 in the tenths place, and this has a 3 in the tenths place. We don't need to go any further once we break the tie. We don't go to the hundredths and then see which is greater than the hundredths, because the tenths are worth more than the hundredths. So if this has 3 tenths and that only has 2 tenths, then this is going to be your greater number. So the wider part of the symbol faces that greater number, and you're good to go. Number 2 is 41%. And draw yourself a nice big comparison circle there, compared to 0.401. So again, this one is already in decimal form, but this one is in percent form. We talked about with percents, it's just out of 100, so you would just divide by 100, which moves this decimal point, if there's unwritten, it's all the way in the front here, moves it 2 spaces to the left. It would be 0.41 or 0.41. And this is 0.401. So let's talk about this one here. Now they're both in decimal form, just compare the place value. Both have 0 in the ones place, 4 in the tenths place, we're still tied. In the hundredths place, this has 0 and this has 1. So even though this has more numbers after the decimal, that doesn't matter. It's all about place value. This 1 is the first place where we had something different than this number. This is just 0. So this breaks the tie, and 41% is greater than 0.401. You could also read this in problems like this. You can read either forward or backwards. You could say 41% is greater than 0.401. Or you could read this direction, say 0.401, and because as we go from right to left, we hit the smaller part of the symbol first, we could say is less than. So if we go in this way, we'd say 0.401 is less than 41%. So you can actually read these either forward or backward, and they still make a true statement. Number 3 is 4 3/8 compared to 4.375. So again, we already have one decimal form here. We'll need to change this one to a decimal using long division. So let's go ahead and put the numerator on the inside, denominator on the outside. Fill in some zeros here. We already have a whole number here of 4. So we have 8 goes into 30. That'd be 3 times. 3 times 8 is 24. And we subtract. Borrow from the 3 there. 10 minus 4 is 6, and bring down a 0. 8 goes into 60. Well, you have to think about how many 8s would fit in there. 8 times 7, let's try 7. 8 times 7 is 56. And I think that's as high as we can go without going over. Borrow from the 6. 10 minus 6 is 4. 5 minus 5 is nothing. Bring down a 0. Okay, 8 goes into 40. That's going to be exactly 5 times. 5 times 8 is 40. And we're done. So sometimes you do need to go to 3 numbers after the decimal here, because in this case they're tied after the ones place, the tens place, the hundreds place, and the thousands place, and there's no more digits to compare after that. We couldn't keep going with this and add more digits because we zeroed out there. So these 2 numbers are exactly the same value. So you got to be watching out for this, because sometimes they really are exactly the same and they're just equal. All right, well, we haven't actually done any irrational numbers yet. We've done all rational numbers. Numbers can be written as fractions, and we're supposed to be comparing real numbers that include irrational numbers as well. So we're going to have one here in number 4. We have 8.72 compared to, and it's going to be the square root of 79. So there's our irrational number. It's not a perfect square. So this is already in decimal form. This is the square root of 79. And so we'll need to come up with an estimate for this. And we're going to need to come up with one that we feel pretty certain is correct. So we're probably going to need to use the guess and check method, because that's going to be the best way to do this. So we're going to go ahead and we're going to try just one number after the decimal and see if that's decisive enough. If not, we may need to go two numbers after the decimal. So we need to write the two perfect squares on either side of 79. We have 64 on this side and 81 on this side. Let's show the square roots of all those. Square root of 64 is 8, and the square root of 81 is 9. So we know we're between 8 and 9. That doesn't help us decide which one's greater or less yet. It's the same whole number. We are quite a bit a ways away from 64 here. We're 15 away from 64, and we're just 2 away from 81. So we're awfully close to 81 here. So this is going to be 8 point something very high, close to 9. So we could try 8.9 and see how close that gets us, if it gets us close enough to 79. And 8.8 might be a better estimate, but let's try 8.9 and see how that goes. 8.9 times 8.9. Let me do that up here. You guys should have some space up there at the same place in your notes too. So 9 times 9 is 81. Let's put the 1 there. Regroup the 8. 9 times 8 is 72. Plus the 8 is 80. Okay, fill in the 0 here. 8 times 9 is once again 72, so put the 2 there. Regroup the 7. And then 8 times 8 is 64, plus the 1 is 71. So let's add this up and see what we get for this. 1 plus 0 is 1, 0 plus 2 is 2, 8 plus 1 is 9, and 7 plus nothing is 7. Two numbers after the decimal here, so we'll put two numbers after the decimal in our answer. We got 79.21, and we were shooting for 79. So this was a good estimate. We were within 0.5. I don't think we need to check again. This was a little bit high, but I don't think 8.8 is going to be any closer. We've talked about if it's a square root of 20 or less, if you're within 0.5, you might need to take another guess. But this is going to be a pretty good estimate here. So 8.9 looks like our best estimate here. And that's different enough from 8.72 that I'm fairly certain this is accurate enough for us to say that this number is going to be greater. So we got 8.72 and 8.9 or 8.7. They both have the same whole number, but this is where things get different with the 9 in the tens place, the 7 in the tens place for that one. So that number is greater. So we're going to be doing some more comparison on your own in class. We'll talk about some of those problems. But that should give you a good introduction to that.